James, that was extending a pattern. Now we're going to move to finding the missing element in a pattern.
Yeah. I know what to do here. I guess to quickly make a pattern. If you have two triangular pieces, I guess a square shape, another triangular pieces, and a square shape. If you had a pattern like that, I could then come up to the children and say, right, what's missing, right?
Okay, and that's really what it's all about.
Yeah.
But I like to cover it.
Oh, cover it nice.
And then the children decide what's missing. Now this is very challenging because they have to go back and look and see what the element is that repeats.
Sure.
So it is a very good experience, and the brighter children love making these up for the rest of the class.
Oh yeah.
So it's a very.
Would you ever
nice
cover more than one piece in there? Or?
I haven't because I work with young children, but I think you could.
Yeah, yeah, most definitely. Great. Rose, you're up to the last, and I think the 7th stage. So what's that about?
This is translate a pattern.
What's translating?
Translating is showing that pattern with other movements or objects, showing
another
that
way.
same, yes,
Yeah, so
another
you
way.
say
Right.
the same pattern another way using other materials.
Yes. So an example would be that if we're using, I could give the different colors a different motion. All right.
Okay, so you're going to use concrete resources here.
And then I'm going to do an action.
Some actions. So let's suppose then you, I won't get you doing anything too crazy, but let's say you did, where's my pointer here?
Okay.
Got a pointer here,
So
so I need.
I can
On this one, clap your hands.
All right.
And on the red, we're going to click your fingers. Is that right?
Okay. All right.
So here we go. Ready?
Here we go.
Clap,
clap, snap, clap, clap, snap, clap.
All right. So you're showing the same pattern another way.
Yes.
All right.
And
so
then,
after you've done it with concrete resources or body movements,
then I like to go to pictorial. So you could use a pattern book. All right. So here's any book about patterns that you can see the repeating pattern.
Right.
And so in this one, we could do the same thing. We could do actions. I could say every time there's a triangle, I'll touch high, and then for the X's, I'll touch my toes. So we go touch high, touch toes, touch.
I guess I could still do this, couldn't I?
Yes.
And show the patterns this way.
Yes. Yes. All right. So you're using concrete.
Brian, let me introduce you to Michael and Gemma.
Hi kids, do you think you could show us 11 fingers? Let's see 11. Look at this. Now James, this is what made me realise how powerful this was. I started to do this in classrooms about 15 years ago, and in all the hundreds of classrooms I've done it in, when I ask students, is this 11, how do you know what they don't do? They don't count Michael's fingers. Now there are 10 ones there just all ready to be counted, but they see it as a collection, 10, and they say to me, yes Mr Tickle, that's 11 because it's 10 and one more.
Yeah, they know that straight away, that's 10.
They see the 10 as a collection. So let's go a little bit further. I wonder if you could make it 14 fingers for me. Lovely, nice big 10 there. When I ask for 14 fingers, and I've even had it with 4-year-olds sometimes, some students will say, even at that early age, that's 14 because it's 10 and 4. Others that are nearly there will say, it's 14 because 10, 11, 12, 13, 14. And that's good too because they're counting on from the 10. One more, could you show us 16 fingers? And when they see that, they can see it's 16 because it's 10 and 6 more. And 4 more would make 20. They begin to see, if I know 6 and 4 make 10, 16 plus 4 is really easy to do.
So that's numbers up to 20. How do you go about doing beyond 20?
All we need is a few more kids.
Well, let's bring in another child and we'll see how we go representing numbers beyond 20.
Sure.
So here we have a story. It's about 10 hens, 10 happy hens, and the 10 happy hens are digging by the door, and 6 ran out. So we've got our language run out. Tells us in everyday terms what's happening. If there's 6 run out, then there are 4. So in this particular case, we're starting with language that relates to the idea of takeaway subtraction.
Takeaway subtraction, it's just natural language.
So if we take that same situation, we can do hens with missing addend subtraction.
And what have you got to show us?
I've got a pen. I'm going to show you a chicken pen now.
You grab the pen and I'll side.
So this is our pen, and we've got some chickens, and I'm going to place the chickens in the pen.
How many?
We'll put 6 in the pen. And there's a number outside the pen. There's a number of chickens altogether. I'm going to tell you there's 10.
There's 10
so
altogether.
How many do you see?
There's 6 there, there's 10 altogether.
Okay, you don't see them, but
No.
I need to put some here so there are 10. So what am I going to do to show 10?
You'll need to add another 4.
That's right. So I know the total, 10.
Yes.
You can't see them all, but you can. You know the total is 10, and you can see a part.
So this is the missing addend.
That's right.
We know this addend, there's a missing addend, and we know the total's 10.
That's right. So we might have the chickens at night. Some are here, some are still yet to come. How many more are still yet to come? So that would be our story for missing addend.
Missing addend. And what about difference?
But for difference, we could talk about some chickens who are in the pen and some chickens who are outside the pen. And you might say, well, how many chickens do you see inside?
6.
How many do you see outside?
3.
So how many more are inside? How many fewer are outside?
Well, what's the difference?
What's the difference?
The difference is 3. There's 3 more chooks inside. For our American friends, we sometimes call these chooks here in Australia. Chickens.
Chickens. So what's the difference in the number of chickens? So in this particular case, the total would be what's inside. One of the parts that's known is outside, and the missing part is the difference. So it's a little bit more abstract.
Okay. So where do you start?
Well, what I like to do is start with a concrete model. And so let's start with the bridge to 10 frame. So you have 9 showing in the 10 frame. And then what I'd like to do is to be able to add 5 more to that. But for many children, that's a hard fact for them to know.
Yeah.
And I want to use more of a strategy approach. So let's change that 9 and 5 and slide that chip over, if you would.
So
And
9 and 5.
Same as, what do we have now?
Now we have a full 10, so 10 and 4.
That's right. So we've taken 9 and 5 and we've bridged to 10 or completed that 10 and made that 10 and 4.
Right.
So I like to start with the concrete, but I don't want to leave it at that. I want to then take them to a pictorial representation. Right. So essentially we have the same thing here. We have 9 and 5, but what I'm going to do is again fill that frame. So now I have 10 and 4.
Yeah.
But what's so powerful with this one is it's not just about that bridge to 10. This is a visual representation of the associative property.
Yeah.
What I start with is I have 1 associating with the 4 below.
Yes, that's right.
And then when I move it over, the 1's now associating with the 9.
Let's record what you just said.
Okay, so what we want to do is start with the 9, and we have the 1 grouped with the 4, or associating with the 4. And then as we flip this over, we now have the 1 associating with that 9.
So 9 and 1 and 4 is the same, or 5, is the same as
9 and 1.
9 and 1,
or 10
10,
and 4.
4 more. The associative property.
Right.
Sandy, why are you using the pictorial model here?
Because unlike the concrete model, this gives us a nice visual representation of the associative property. So I can show that the 1 is associating with the 4 to start, and then it is switching and associating with the 9. So it gives me that visual representation of the associative property, unlike the way we traditionally do it, which is very rule-based. So we may call it a bridge to 10 strategy, But as we said earlier, it's actually the associative property.